Okay, hello, good morning everyone. Our lesson this afternoon is all about Calculus 1 with Analytic Geometry. So for this, the learning and studying calculus is quite challenging. Why challenging? Because it needs your mastery of the two requisite subject, the Euclid's algebra and trigonometry, plus your analytic geometry. There is a need for us to master the subjects because we cannot pursue with the topics not unless we can understand the given situations like limits, trigonometric functions, and all of this. It also involves the mathematical operations in calculus are differentiation. In this subject, you are going to differentiate the given functions. It involves mathematical operations involving derivatives. It's based on the notion of limits on step-by-step process and extended to an additional type of functions. It also includes differentiation of algebraic functions, the rules for finding the derivative, and other differentiation like chain rule, derivative of reciprocals, derivative of rational exponents, higher order derivative, and implicit differentiation. Okay, we're going to tackle first the limits of a function on page 1. With the following objectives, we have explained in your own words the meaning of a limit of a function, and number 2, determined whether the graph of a function has a limit of a given point. My dear students, if we're going to learn what is a limit of a function, that is just similar to limit in our time in having a Facebook. We're going to have a limit of 1 hour. That's a limit. We're going to have a limit of 2 hours. That's it. We're going to set our limits. So if we let the values of the independent variable approach to a certain fixed number, let's say for example, as far as independent variable is concerned, the amount of money that you're going to pay for the gasoline, it depends upon the distances covered. Meaning to say, the independent variable is the distance covered, and the dependent variable is the amount that you are going to pay. So what happens to the values of the functions? Meaning to say, the values that you are going to solve, the dependent variable depends upon the independent variable. The one that I have given you, okay, let's say for example in this situation, for example, f of x equals 2x plus 3. Or we set f of x as y. The value of this y, f of x, on page 1 is equal to 2x plus 3. Our x is the independent variable, and it depends upon for whatever values that you are going to substitute for x. You can substitute x for 0, 1 up to the number you wish to substitute. And of course, the value of f of x is y greatly varies about this value. And select values that get closer to 4, and then you're going to graph this. As you see it in your page 1, there is a graph of the functions. That is a linear function. The value of y or the f of x depends upon the given values of your x. Simply substitute this x to a certain values so you can have the value here. So on the next page, class, page 3, as you see it in your module, these inputs approach from the left. We have here the values of x. When you substituted the equation as 2, it's simply 2x plus your 3, and 2 times 2, that is 4, because you substituted x by 2, will give you 4 plus 3. And now, your f of x or y is equal to 7. That is why we have this 7. And we have the values of x, that is 3.6. You will substitute this to the linear function, 2 times 3.6 plus 3. That will yield the value of y, which is denoted as f of x, which is equivalent to 10.2. And to continue, you're going to set the value of x as 3.9. So f of x is equal to 2 times 3.9 will give you the value of y, or the value of f of x is equal to 10.8. As same with step number 1, 2, and 3, when you set values of x as 2, 3.6, and 3.9, as well as 3.9, you will yield this value 10.98 and 10.99. But if you're going to set the value of this, 2 times this one, 4, this is 2 times 4, 8, plus 3, that will give you 11. Then from this is the domain and the range. Again, these are the values of x, and these are the values of y. We're going to plot this in the Cartesian coordinate plane. So if x is 2, we have this value. The value of x is 2. We have the value is 7. Here. If this is 2, the value of y is 7. Dili ra moabot sa 8. Tanawa. So if you will set the value is 3.6, the value of y is, we have the value of y, 3.6. Where is the value 3.6? This is 2, that is, okay, 3.6, that's equivalent to 10.2. This is the value. So you continue, and this is the graph of the given function, the linear function. So as you see it in the arrow, it is often used to stand for the words approaches from either side, upward or downward. Since we have the arrow, this is unlimited, this is a line, this is extended indefinitely, upward or downward to opposite direction, and this, therefore it is a line, and it follows a linear function. So the number 11, if you are going to follow the computation, f of x, the value of x is 4, 2x plus 3, 2 times 4, that is 8, plus 3 is 11. And you are going to substitute everything that is found in all the domains, and we have the corresponding values of the range, that is the y values. So we have approaches a as a limit, and written as the limit of f of x is equal to L, and x now is approaches to a. If all values of x are closer to L, for values of x that are sufficiently close but not equal to a, the limit L must be an equal and real number. Okay, we'll have an illustrative example. Okay, let f of x is equal to x raised to the power 3 minus 1 over x minus 1. Simply, you're going to substitute for the values of x. What is now the values of x? We will set the value is equal to 1. 1 raised to the power 3, that is 1. 1 minus 1, that is 0. And what is the limit of x as x approaches to 1? So we have here the answer. The answer, for we get 0 as the value of the denominator. The solution is shown below is 0 over 0. So as x approaches to the value that is equivalent to 0, because the value of x is 0. Hence, the limit of 1 does not exist if with the graph. We cannot see a point on the graph of x when the limit of x is equal to 1 as illustrated below. Kung 0, wala may makita, kay 0 man siya. So, as it approaches to 1, we have the value. X is greater than 1. So, our x is As x approaches to or greater than 1, we have the value 1.1. And f of x, you're going to substitute again this value, the given equation, 1.1 minus 1, and that is 1 minus 1. All you're going to do is substitute the variable x by the given values of set in the domain, and you have the corresponding values in the range. So if you will set x as 1.01, you will have the f of x, the value of y, that is in terms of limits, 2.01. So for the example number 2, let us choose values of x near to 1 on both sides. And we have here, and you will see that the function values get closer and closer to 2. Hence, the limit f of x as x approaches to 1 is equal to 2. Why? F of x is equal to 2 kaya there is only one variable. Wala na daghang mga numerators and denominators. All you're going to do is to substitute the value of x. Okay, we have to limit numerically. As it approaches to 0, the value is 2. As it approaches to 0.5, the value is 3. 0.8, the value is 3.6. So we have the same values.